Everybody, Bryce here. I'm at home and I'm going to show you how to do some graphing because unfortunately I'm going to be out tomorrow. So I have here a set of car and ramp data and stuff from the lab that we did last week. You'll remember we had a cold day, so it's a little bit dicey on how all those things went down, and I have a meeting tomorrow. But what you should have is all of your data, all your times put in here from the photo gates where you have time A, time B, and time AB. You have all your photo gate locations, and then you have your wing distance. Now, most of the classes have a wing distance of 1 centimeter, but we aren't really using the wing, we're using the ball. So I'm going to actually just change that right now, ball distance. And so that gives us a length that all this is going into. And then here's all the speeds. Now, these I calculated with equations, and so you can see my equations there. But that doesn't matter. You might have done these by hand. All of these also we could adjust so that there's just a few less decimal points showing, and it changes our graphs a little bit, you can see. But what we really want to get to is how you build these graphs. So there's this position time graph over here, velocity time graph, and the last one is an acceleration time graph. And what I really want you to notice are all of these patterns that exist. This is sort of curved, this is straight, and this is totally flat line. But we're going to go through and I'm going to delete these just so that we can see how these were built. I'm going to leave that one. And so if we want to build a position time graph, we're going to need to do that by very carefully selecting the pieces of data we want. First, I'm going to get the time, and then I'm going to get my position. So that's where the photo gate was. I'm going to hold down Control, select that, and then say Insert a chart. And you can see Google Sheets put in a chart, but it's the wrong kind. So there's a column chart. I'm going to change it to an XY scatter because that's my favorite. You can see already the points popped out. These look like my location data points, and these look like my time points. So it looks like we're good there. Plus over here it says x-axis is time, and the series or the y-axis, those are my positions. I can use row 1 as headers just so that it sees those there. And that's it for the data side. But this graph is pretty bare. Right? If I have a graph like this would not be how I'd want to submit it if it were for homework or something that was due. So I'll need to do some chart titles and say the chart title could be position time graph for ball going down ramp. And so maybe I needed to capitalize some things there, but we'll just go on. The horizontal axis, I need to make sure that that is labeled. That would be the time in seconds. And then I could make a note, it's the AB time. Yeah, we're gonna say time in seconds, and then I'm gonna put in brackets AB time, just so that we know. Then my vertical axis, that would be my position, and that would be in centimeters, and distance from PG A, from PhotoGate A, and I might just for the sake of knowing that that's a note, put it in the brackets as well. But always when you're making these axis labels, you want to be as specific as possible. And so we're doing well there. But what I really want to do for my series is I want to add a trend line. And you can see linear doesn't fit super well, but I can change the type. It should be a polynomial graph, a second degree polynomial. And if you're curious about why, you could talk to your math teacher because it's a really interesting question. Or take physics when you're a senior. Either of those will show you. But that's it, and I want to make the label, use the equation. I always like to have that there for me so that I can see what's going on. So that was how to make the position time graph, and it's from location and time AB. Now we're going to do the velocity time graph, doing pretty much the same thing. We're going to do time AB, hold Control, and then my velocity. I care about my speed B because that's how my speed or my velocity changes over time on the graph. So I'm going to go back to Insert Chart. You can see they got it wrong, so I'm going to do this real fast. You guys already know what I'm doing. X-axis is time, y-axis is speed, use row 1 as headers, cool, customize. Series, let's add let's go back and do the titles. Vertical axis title, this would be velocity, centimeters per second. And this is PhotoGate B, instantaneous velocity. And so you can see that's kind of long, but it's fine. And then my horizontal axis title, this would be time in seconds. And this would be time to get to, what did I say for the last one? AB time. We'll just go with that. You know that means it's the time to get from photogate A to photogate B, but we'll still go with it. And then the last one would be the chart title. So this would be a velocity time graph, and for ball rolling down a ramp. Perfect. Okay, so those things are there. We've got our chart axis titles. Next up is our series stuff where we want to add our trend line, and you can see this does fit a linear graph. And so I'm going to again show the equation right there and put this thing back into place, and you can see that that was it. That's all it takes to build these graphs. You can see we've got labels that are nice and clear, very specific. Our title's got everything we need. And so all the data is there and it fits. And then here's acceleration time, which you can see is a flat line. It's very much the same, but this would be acceleration over your photogate AB time. Now the reason why we use photogate AB is because that's how much time since like the start of the ball rolling down the ramp, since it's considering the photogate A the start and photogate B the finish. Each time you checked it, it was like the new finish line as you went. So that's an important part. And seeing these graphs in this way keeps it consistent with how you've seen it in other ways. In fact, it would be a great question for us to ask you how to identify that this is similar or different from other position time graphs, because there's a lot of ways to build these, and so they all make for good questions. Either way, that's it. Hope you can make these graphs and be ready for discussion on Tuesday. All right, I'll see you then, guys. Bye.